Okay, in this video we're on to section 7.3. We're looking at special products for polynomials. So let's go ahead and take a look at our learning targets for this video. By the end of the video, you will be able to use the square of a binomial pattern, and you will also be able to use what we call the sum and difference pattern. Okay, so let's take a look at our core concept. First, we're going to look at the square of a binomial pattern. So go ahead and pause the video and copy down these two formats here. So we have the algebraic format. So we're multiplying a binomial to another binomial, a plus b times a plus b. So if we see a plus b quantity squared, it's the same thing as a plus b times a plus b. And when we do that, this is going to be our product. Likewise, if we have a minus b times a minus b, here's our product. Now here's some explicit examples. So we can see if we have x plus 5 squared, really that's just x plus 5 times x plus 5. And one way to find the product is just using FOIL. So FOIL will work, but if you recognize that there's a pattern that's occurring, that can just be a shortcut to getting the solution or the product quicker. Okay, so looking at using our square of a binomial pattern, I can see that this first example here is in the format of a plus b, and we're squaring it. And if I use that formula that we copied down from our core concept, this is equivalent to a squared plus 2 times a times b plus b squared. So in this example, I can see that the 2x is equivalent to a, so a is 2x, and the b is 6. So if I just substitute in what I know into this format, I'm going to have 2x squared plus 2 times 2x, which is a, times b, which is going to be 6, and then I'm adding b squared. So b is 6, and then I'm squaring it. So as I simplify, 2x quantity squared is going to give us 4x squared. 2 times 2 is 4, times 6 is 24, so the middle term is 24x, and then the last term is 6 squared, which is 36. Okay, let's take a look at another problem. So we have 3x minus y quantity squared. So again, we have a square of a binomial pattern, but this looks more like a minus b squared. And if we refer back in our notes, we know this is going to be a squared minus 2ab plus b squared. Okay, so in this example, 3x is going to be equal to a, so a is 3x, and we can see that b is equal to y. So when we substitute into this format, we end up with 3x quantity squared minus 2 times 3x times y plus y quantity squared. So when we simplify this, we end up with a 9x squared. Negative 2 and a positive 3 is a negative 6. And then we have x times y, and then we're adding y squared. So this is the product when we have a square of a binomial where you're subtracting the b. Okay, let's take a look at using our sum and difference pattern. So again, pause the video and copy down the sum and difference pattern in your notes. And you can see algebraically the sum and difference pattern looks like a plus b times a minus b. So the difference with the two polynomials or the two binomials is the sign. And when we multiply them together, it simplifies to a squared minus b squared. So let's look at an example here. Without using the pattern, let's just FOIL what the product of these two binomials will be. So if we multiply our first terms together, we get a squared. If we multiply our outside, we get a negative 8a. If we multiply the inner terms together, we get a positive 8a. And if we multiply the last terms together, we get negative 64. So we can see that the middle terms here are canceling out, and we end up with a squared minus 64. So we could have predicted this using our pattern, but FOIL will always work also. Okay, our next example, we are going to use the sum and difference pattern to figure out what the product is for 4x plus y times 4x minus y. So looking at this, we can see that our a is equal to 4x and b is equal to y. So if we follow the pattern, the product is going to be a squared, so 4x squared, and we're subtracting b squared. So when we multiply this out, we end up with 16x squared minus y squared. So in our last example, we're going to see how using special product patterns can help us with mental math. So if we look here at the product of 48 times 52, is there one of the special product patterns that we've looked at today that can help us multiply this out rather than us going the long way to multiply? And if we rewrite 48, we could write 48 as 50 minus 2, and we're multiplying this to 52, which would be 50 plus 2. So which special product pattern is this? And hopefully you said this is our sum and difference pattern. So when we multiply this together, we have a minus b times a plus b. So we're going to have a squared, so 50 squared, and we're going to subtract our b squared. So 50 squared, well, that's just 5 times 5, which is 25, and then we're going to add on 2 zeros, and then we're subtracting 2 times 2, which is 4. And when we do this, we get 2,496. So by recognizing a pattern, we're able to mental math this product pretty quickly.